All right, guys, got something brand new for you guys today, polar coordinates and graphs. And you can see below the title there, that's what a polar graph looks like. So, not something you're used to, more circular than rectangular. So let's see what happens. Two key terms you need to know. First one is pole. When you're graphing polar coordinates, the origin is actually called the pole. So the point 0, 0 you're used to is called the pole. The polar axis, not like the North Pole, but the polar axis is the positive half of the x-axis. So those are the main two terms you need. Really, you got those two terms, you can do what we're doing today. So I hope it's not too bad. All right, a few examples here. What graphing a polar graph looks like. Look at the point A right here. The point A says 460 degrees. Found 60 degrees. And if you notice, the polar graph is made up of a bunch of concentric circles. Here's our pole. And I went up to the fourth circle. So that's why the point is 460. Look at this right here, 390. It's 390 because it went all, if you go all around this 360, come back up to 30. It's on the fifth circle, 1, 2, 3, 4, 5. So it's 390. Let's pick a couple more here. B says 3 pi. Remember 180 is the same thing as pi, and it's on the third circle. So it's 3 pi. Notice the circle number comes first and the angle comes second. Look at G right here, 6, 3 power 4. 3 power 4, same thing as 135 degrees, so it's 3/4 of the way to pi, and it's on it should be the sixth circle, 1, 2, 3, 4, 5, 6. So that's how it works. Not too hard to graph the points, but a little bit different. Okay, graph each of the following, and what I did is I went ahead and put the picture down here of them already graphed out. But the first one, A, says 3 and 60 degrees, so I found 60 degrees first, which is right here. And I go up to the third circle on the graph. Just so you know, I will be giving you polar graphs tomorrow, like the circles. So you'll be able to use those. So don't worry about having to draw that every time. Part B, 0, 10. Okay, so 0, which means not even going anywhere. 10 degrees. Look where B is. B is on the pole because it has 0. So even though it's 10 degrees, because you're not leaving the origin or the pole, because you're basically your radius. Your radius is 0. Your radius is what comes first. I keep saying circles, but that's what the radius is of the circle. There's a number in front. So like C, -5, 120. I'm going to go to 120. I'm going to go to the fifth. Radius is 5, but instead of going up here, because it's -5, you go the opposite direction. That's why C ends up being way down here at the bottom of the circle. Let me change colors here. 2 and 3 power 2. 3 power 2 obviously is it's down here. That's the y-axis. And I'm going to go in radius 2, which is right there. So that's why the E is down there. The F, I'm skipping D on purpose. That's okay. F says -4 power 3. Power 3 is 60. Because -4, I'm going to go radius 4, but I'm going the negative direction. So I'm going down here. So the 60-degree angle in quadrant 3. Hope that makes some sense. We'll go over a bunch of those again tomorrow, but those are pretty good. All right, some things you need to know before we do the next part. One more part here we're going to do. First of all, when you graph a point, or whether it's a coordinate plane or a polar graph, if you graph the point P, it's XY on a rectangular plane, but if you're doing polar, you do R theta. Remember R being your radius, theta being the angle that it makes. So here's what R is, and it's the same thing we used to do with R. R is the square root of x squared plus y squared. It always has been. Remember cosine's x over r, sine is y over r, tangent is y over x. So in that case, because that's the case, that means x is r times cosine theta. That's just by cross multiplying right there. Y is r times sine theta. Just by cross multiplying. So when we need the x and y, that's what we're going to do, and vice versa. So let's try a couple here. What they're going to have us do is they're going to say, okay, let's convert these 2 points into polar coordinates. So to need polar, I need the r and I need theta. So for r, I'm going to say, okay, r is the square root of x squared plus y squared. So I get 9 plus 9, which is square root of 18. 18 breaks down to 3 on 2. So there's my r. Now I need my theta. The quickest way to do theta is do tangent. Remember, tangent's y over x. So it's just 3 over 3 or 1. Where's tangent 1? Pi over 4 or 45 degrees. Either way you want to go. So what that means for my point is, my point is going to be 3 and 3 squared of 2 and also power 4. So I'd write like, and because this is in quadrant 1, the point's in quadrant 1, I don't know what I'm doing right there. I'm trying to talk right. You can use the quadrant 1 angle, which is power 4. Power 4 is in quadrant 1. You could also write it this way, 3 on 2 and 45 degrees. Okay, let's try the other one over here, just to make sure you got it. It says this is my rectangular, so I'm going to do my R, find R first. I'm going to do 2 on 3, square it, -2, square it. So I would get, let's see, if you square 2 on 3, it'd be 4 times 3, which is 12. Square this and you get 4. That's 16. The square root of 16 is just 4, so there's my R. And again, the best way to find your theta is do tangent. Tangent would be it would just be y over x. Looking at that, those cancel. That would leave -1 over square root of 3, which is really negative square root of 3 over 3. And we know what that is. That's a power 6. So my theta is going to be a power 6. Now, what I'm looking for now is, okay, what quadrant is that in? If I go, it's positive, negative, which is quadrant 4. So I got to remember what the power 6 in quadrant 4 is. It's 11 power 6, which is all I need. So to change it to rectangular, I would do my R, which is 4, and my theta, which is 11 power 6. If you did degrees, you would say 4, and then that would be 330 degrees. All right, one more slide. Let's go backwards this time. All right, so I need to change my polar coordinates to rectangular. So what that means I need my x and my y. And remember from a previous slide, we had cosine theta is x over r, which means x is r cosine theta. So I have both of those. R is 10, theta is power 3. So I'm going to do 10 times cosine power 3, which is 10 times a half. So that's 5. And to get my y is just r sine theta. I need to write that again. Y is r sine theta. So r is 10, sine power 3. Sine power 3 is square root of 3 over 2, which would be 5 on 3. So my rectangular point coordinate in that case would be 5 and 5 on 3. All there is to it. Let's try one more just to make sure you got it. This one's same deal. I need my x and my y. X is always r cosine theta, so it's -5 times cosine of 135. Cosine 135, that is a 45-degree angle in quadrant 2, so it'd be negative square root of 2 over 2, which would be 5 on 2 over 2. That'd be my x. My y coordinate, -5 sine 135. You know what? 135 is a 45. So the sine value, except it's quadrant 2, sine is still positive in quadrant 2. So my y is going to be -5 on 2 over 2. So my point for that one would be 5 on the square root of 2 over 2 and -5 on the square root of 2 over 2. Okay, so shouldn't be that bad at all. We'll work on them in class like we always do. I always say that every day, so you should know that's coming. But anyway, I'll see you in class tomorrow. Look forward to it. See you. Bye.